Hello and welcome. In this video I'm going to complete a series of tasks on OcNOS routers on ISIS routing protocol. So I'm going to show you the tasks first, and then we are going to take a look at the topology, and then we are going to get our hands dirty with the configuration. So the first part says that configure ISIS on backbone and POP devices as per the diagram. So this is quite simple. Of course, I have done this before, and I'm going to show you the configuration. And after that, it says that ISIS metric on the length should be set to 1000. This means that we need to change the metric style to wide, and that should be done under ISIS process itself. And under each interface, then we can configure the ISIS wide metric to 1000. So there are two different commands, ISIS metric and ISIS wide metric, and you should make sure that ISIS wide metric is configured under the interfaces. I have done this in a previous video, so I'm not going to do it here, so just skip this part. But this part, of course, is simple and interesting. It says that we should assign a tag 2 to host routes of backbone and tag 2022 to host routes of the POP devices. So you should know that host routes mean here loopback interfaces which are configured with /32 masks, and assigning the tag is going to be super simple. It should be done under the interface configuration. Now, the reason that we create these tags are interesting. We can use them for redistribution. We can match these tags under a route map and then assign that route map to redistribution from level 2 to level 1. And one of the reasons is whenever, for example, I have a level 1 area, what is level 1 is going to receive is just a default route. And sometimes I want to redistribute the host routes into there because we want to have MPLS, and LDP needs a default. LDP is not very happy with default route. LDP really wants the host routes. Of course, with the recent advancements and new RFCs, this is solved. But for now, assuming that there is no such thing, we are going to make sure that we have some loopback interface information in L1 domains, and then we can just create LDP labels for them. Okay, let's start with this. What I'm trying to do is first one, I'm going to show you the configuration of that. So what I have here is a backbone area. You can have multiple backbone areas, but you should make sure that all of them are connected to each other. And then we have POPs. Each one of them is connected to one of these backbone routers. If I just zoom into this part, which is of more interest for me, you can see that in the backbone I have 3 routers, all of them connected to each other in a broadcast network using a switch. And also on the right, area 5, which I'm going to work on, that is connected to R2 using a point-to-point link here. And the rest of the links, of course, could be configured as point-to-point because we do not really need to have an extra LSP there. So what I need to do is to just check the configuration right now for you. On R2, if I just go to R2, and I'm going to say show running configuration of router ISIS, you can see that under this, I have set IS type to level 2 only. That is because I don't really want to have any level 1 connection under the backbone area. Dynamic host name is used. This means that instead of this part of the network entity title address, which is the system ID, I'm going to see the router name, which is R2, in the advertisements. Also, I have made sure that the loopback interface is advertised and it is passive. For loopback interface, we don't have any specific configuration other than just assigning this to ISIS. The other part of the configuration, of course, verification, says that show CLNS neighbor. We are in adjacency with router 7, router 3, and router 4. Now, 3 and 4 are backbone again, and router 7 is in area 5, and you can just see that. This is the MAC address of router 7, as a matter of fact, that you can see as SNPA here. Okay, so let's take a look at router 7. This is my router 7. I'm going to say OcNOS for the login, and I'm going to go to here to say show run router ISIS and hit enter. This is the configuration of that. IS type is by default level 1.2. I have not changed it, and dynamic host name is used, and also the other thing is passive interface loopback 0. Here if I say show CLNS neighbor, you can see that I have adjacency with router 2. For now this is not completely done. You can see this system ID, but after some time you should see that R2 is going to be displayed here. The reason being is router 7 has been reloaded and it has just come up. And if I just check show IP route, I can see that I have not yet received any route from there. But after some time this is going to have something which is called attached bit set to that. Router 7 is an adjacency with router 5 and 6 in area 5. So if I just go to router 6 for example and say show CLNS neighbor and hit enter, you can see that I am in adjacency with this. And if I say show ISIS database, this says that I am receiving stuff from router 7. For now it says there is no attached bit set on router 7. Router 7 is not completely loaded. I'm just waiting for that to come up. And after some time you should see that attached bit is set to 1. The reason is router 7 is connected to another area. So it should advertise attached bit in the database. So let's go back to router 7 and see when this is going to completely come up. So if I just go to CLNS neighbor, it is yet to come up, and let's just take a look at the configuration one more time just to make sure that there is no problem with the configuration. So you can see that the domain password is set to WR. I'm going to check to make sure that router 3, 4 and 2 have this configuration set to them. The reason is this is for level 2 LSPs. So let's go and check them on router 2. On router 2 you can see that there is no domain password. So I just make sure that the domain password is set on this. I'm going to commit this and WR. This is going to fix the problem. Router 3, I should have it on this, and I'm going to say commit and WR. And finally router 4 should have it, and commit this and WR just to save the configuration. So going back to router 7, now I should see everything is fixed. So if I just say show CLNS neighbor, it is fixed. Now if I just check show IP route, you should see almost everything here. Very good. Going to router 6, I should see this attached bit set on router 7, which is correct. And if I say show IP route, you can see that I am receiving this default route because the attached bit is set for router 7. Okay, so the first part of the configuration is completed, and I have done it here. The second part, like I said, is super easy, but I'm not going to do it. I'm going to skip that. Now on backbone devices, I'm going to assign a tag of 2 to loopback interface. That is super simple. Again, I'm going to go to router 2, go to configuration mode, but before that, let's say I'm going to show running config of interface loopback. Under loopback, you can see that I only have IP router ISIS OcNOS. The other configuration, of course, is super simple. You can see that we can have as many secondary IP addresses as we wish for interface loopback, but we cannot really change anything about primary IP address. That's okay. The same thing about IPv6, of course, applies to loopback interfaces here. I have only one secondary loopback in IP address, and that's okay. I'm not going to do anything more than that. What I'm going to do is to say interface loopback, and I'm going to say ISIS, and after that there is an option that says tag, and I'm going to use this option. So I just say ISIS tag, and the tag could be a 32-bit value, anything from 1 to 4 billion something. I'm going to say tag of 2 as per the task request. So I'm going to say commit, and I'm going to say and save it. the same thing should be done on router 3 and 4. So I'm going to say configure terminal, interface loopback, ISIS tag of 2, commit, and then save the configuration. Here I'm going to say configure terminal, interface loopback, ISIS tag of 2, commit, ISIS tag of 2, commit, and WR. And now for 5 and 6 and 7, what I must do is I should add a tag of 22 to them. So I'm going to go to here, interface loopback, ISIS tag of 22, commit. I'm going to save everything. 6 and 7, configure terminal, interface loopback, ISIS tag of 22, commit, and then save. And finally here, configure terminal, interface loopback, ISIS tag of 22, and before ending I should commit, and WR. Okay, so I have done this, and if I just say show ISIS interface loopback here, let's say show ISIS interface, that would be better. And here we have Ethernet 1, then Ethernet 2, and finally you can see that loopback doesn't appear here, but as a matter of fact this interface is going to be advertised with the tag that we have just configured. Let's do something. I'm going to say show IP route. Here I have all the information from the interfaces. Show IP route, and I'm going to go with 2222. Hit enter. It tells me that there is this entry received via ISIS. The distance is by default 10. I have not configured the white metric, so you see the metric as 10. For now it says external route tag is 0 because I have not redistributed that here, and I don't see anything about that. If I just go to router 2 and do the same thing, show IP route for let's say 5555, and hit enter. Here again we see that external route tag is 0 because we have not redistributed this into here. Okay, so what I need to do is this. If I just go to router 6 or router 5, doesn't matter which one, because we only have 0000, if I say show IP route, let's say 2222, and hit enter, it says that the network is not in table. But because of the default route, of course we have accessibility to 2222 without any problem, right? So what I'm going to do is on router 7 I'm going to redistribute into area 5. So going back into router 7, one thing that you should notice is this. I'm going to show you this, and then we are going to go with workaround. So I'm going to say router ISIS OcNOS, and then here if I say redistribute ISIS level 2 into level 1, you can see that I have no support for a route map. So I need to use a distribute list, and I'm going to do that. Let's say I just type distribute list, and let's say the name is going to be backbone host routes. I'm going to create this and then use it. So let's do this. If I just go to here, I can use an IP access list, and the name is going to be backbone host route. But before that I have the standard, or if I do not type a standard and just go with the name, that's going to be an extended access list. So I'm going to have to type a standard because I'm just going with host routes. So now I can just say permit, and after that you can see that the host could be configured here as 2222, and after that hit enter, permit host 3333, and of course 4444. So that is not the correct way to do that, but let's do it this way. Maybe we can just fix the problem. So what I'm trying to do is to say commit And of course, let's save the configuration. Okay, let's go to router 5 or 6, doesn't matter which one. And what I'm trying to do is to say show IP route. Now I should see these routes, and of course they have been redistributed, so this is why you see inter area here. And whenever I want to create a label for this, this is going to be there, and I can just create a label using LDP and have something like MPLS enabled on them. So like I said, this is a workaround, but the actual support is going to come in the later versions using a route map. So this is why I showed you how you can just tag the routes. Let's take a look at this, and this is what we have. The same thing, of course, could be done when we want to advertise these routes from, let's say, level 1 into level 2 using a tag of 22, but of course, this is not necessary for now. So I'm going to just finish this video right here. So I hope this has been informative for you, and hope to see you in the next videos.